for the great introduction. Thanks also for the invite. It's really a pleasure to be here and have the chance to share my thoughts with you. I just would like to also manage some expectations. Yeah, this will be very high level. I want to really spark your ideas, your creativity also for later discussions maybe in other sessions and so on, and just give a little bit of a perspective for today's conference day. So yeah, as already stated, my name is Johannes Nagele. I'm a principal AI researcher. Researcher is a little bit the wrong term here because I'm basically a consultant and we have no money for research, sadly. But I have the chance to also lead the data science and AI practice in our company, and it gives me also the possibility to look a little bit into the trends, yeah, check out the papers, check out the news, and yeah, see where things are going in order so we can prepare for the business for the upcoming years. Okay, and the topic today of my talk will be opinionated knowledge management. Yeah, it's maybe a little bit off. Yeah, management is not so much the focus on. It's more about how we deal with knowledge, how we share knowledge, and how we can do this with AI in an augmented way that may help us on different levels of our challenges in society. So just a quick summary about my company. So this, what you see on the button is my boss. It's Alexander Tamm. He's well connected in Germany, and you see all the offices also that we have in Germany. We also spread out to Austria and Switzerland in the last years, and we are also like part of the German AI society. Let's not spend too much time on that. So this is just a little outlook from 2 years ago that I prepared for our strategy team back then. And I found it interesting when I was looking through my slides to collect for this talk. I found this again and I was fascinated that all these topics are actually still very valid, or very important right now. And if I would even ask my own employees, many of them wouldn't even know how to define many of these terms still, because it's a very dynamic field, and it's also, for example, terms like agents, AI agents. Everybody has a different idea of that, what this is. But you can see on. Let's try this thing out. Okay, it's working, cool. So here you see also knowledge graphs. Yeah, this is also one of the terms that I will be using a few times today. And you don't need to read all this. This is way too much text, which is also true for many other slides. So don't get confused by that. But I just would like to highlight, if you sort of move from left to right, in the end here, there's also a timeline on the top, and in the end here you see also fluid software. This is a term that I sort of created back then, and I mean with this software that is not software, but it's just AI reacting to us and showing us what we want. I think it's going in this direction. It's not part of the talk today, but I find it an interesting idea to think about. So let's move on. Yeah, exciting times, I already mentioned, super dynamic. I don't know whether this is my bubble, but if I open any of my news app, OpenAI did this, Microsoft is doing that, Anthropic is doing that, and so on. It's like crazy. Nearly like every week we have a new major breakthrough. And this is not only in the field of AI, but also in hardware accelerators or like things like photonic computing, as we also heard yesterday. And many things come together from many different fields. So it's all about connection and perspective. And I think Kjell said, I think 8 times perspective in the intro. And perspective is also a term that will be used frequently throughout the talk, because I will come to this later. So just to give you a few examples of some news that came out lately. Yeah, for example, this meme about this poster, stop hiring humans, hire AVA, the ARBDA. There are a lot of promises out there. Yeah, you can replace people by AI. And I can just tell you from my business, no. Maybe you can code a little faster and so on with the use of AI. And things will definitely also go in this direction. But we always say to the people, either you are you are not replaced by AI, but you will be replaced by people that use AI. So I think this is also one of the philosophies that kind of goes through this talk, because I think it's a lot about how we connect to AI and also are able to share our perspectives with it. Okay, I will not go into all of these news, but maybe this is a very important one that came out, I think, like 2 weeks ago or so. This is the AI 2027 report. I'm sure that many of you have heard about that. Anyone knows it? Okay, at least one. Okay, so then I was wrong with my assumption here. So this is from employees from OpenAI and other really important AI companies. They really created an interactive report, a future scenario for AI. Where could it go until the year 27? And I also won't go into detail on that. But this is one plot that they are showing. And on the top right, you see for 28 USG captured by AGI. That means USG stands for US government. So they are fearing that there's a realistic chance that AI may take over control, so to say. Yeah? And I mean, these are serious people. One of the guys did the same report like 3 or 4 years ago, and most of his predictions were true. However, I doubt it. And I have some reasons for it. There are many reasons, and I'm happy to discuss a lot of them with you in the breaks, but I will try to guide you to the most important reason that I think will speak against this fact that AI will take over control. So what is now happening a lot is we see a lot of collaborative systems, basically agentic systems, AIs working together and working together with the human. That's right now the highest demand, let's say, in the kind of projects that we do. For example, these are use cases like speak to data. So basically, you just have agents that can talk to your database, things like this, and you can do analysis on the fly. This is very nice. It's also fun, and also fun to work with these agents. And here are some benchmarks, just showing this is mostly in the area of coding on the left side. You don't need to understand all of this, but it's basically the saying that if you take a team of agents with an older model version, a smaller model, for example here GPT 3.5, and you sort of give it a programming task, the result is often better than if you use the newest model version that is maybe 10 times as big, and have it only as one agent acting, so to say. Yeah, so the message is that if we use a collaborative system or a composite AI system or multi-agent system, there are really a lot of terms out for this, then through to I would say emergent phenomena or epiphenomena, you achieve better results actually. Yeah, and there are also reasons for that, and I'm sure I will also mention some of them in a bit. But one problem that we have right now in reality is that they are quite expensive to run, because if you let the agent team talk to each other, they have long conversations, and sometimes they end up in a loop saying, "Thanks for the nice conversation." "Yeah, thank you for the nice conversation." "Okay, nice for the nice day." Blah blah blah, and so on. So this is sometimes quite frustrating, but of course for this are also solutions. So you may now think, okay, that's even worse. Now we have even more powerful AI systems than the models that are already out there. If we connect those and build this collaborative systems, then okay, this is even becoming more of a problem that it may take over. But before I give you an answer to this point, I want to just introduce you a little bit to the agent systems. So a little historical perspective. In the early times of AI, we had these very specialized models that were trained to solve one task, right? You all know it, supervised learning, label data, you throw in a lot of data and do some linear regression or some more complex versions of this like perceptrons, and then feed-forward networks, and eventually you build like these really big models that are no more trained for one specific task, but just trained to represent a huge text body, basically the whole internet. And this is like what ChatGPT, for example, is. And suddenly you have a generalist. Yeah? You can, with one model, you can solve plenty tasks. Nice. Okay. But what we are doing now, because maybe you know the principle of, how's it called, no free lunch theorem. Yeah? There's not one model that can solve all tasks perfectly. But there's a trick. We can use this generalistic model and reduce its capability by giving it specific perspectives and specific system prompts, and yeah, sort of tell it how to behave specifically regarding its own specific task. And you can connect different systems from different providers and have these collaborative specialists, and I framed it. Yeah. And yeah, one of these specialists is defined by this. Yeah, agents are nothing new. Many of you probably know it from different fields, from organizational theory, from reinforcement learning, from social studies, from game theory. So this is a term that has not been there only for the last 2 years, but really for a long time. But the different thing is now we are adding some intelligence to an agent, and this gives this gives it really a new meaning. It's a different thing. It's actually something that I waited for my whole life, that I can build like one agent and have really an intelligence behind it, and then I can simulate them, I don't know, running around in an environment and playing some game of life or something like this. Yeah, so agent consists of models. It has a task. This is usually defined in the system prompt. Important is the context. It needs to know in which environment it is, what is the overall use case at all, and so on, to really sharpen its thinking to this specific situation. Then on the left side you see the skills, tools, services, data, and other agents. So this is again about connection. Every agent also, or most of the agents that we are building, also have some capabilities to exchange data with external world or with other services. Ingest data from databases, or talk to other agents, or read some data catalog, read some PDF file, or execute some code and similar things, or maybe send an email. Okay, on the lower ones I will not spend time now, but again, the term perspective. Yeah? One question doesn't have one answer. If I ask you the same question tomorrow, you will maybe give me a different answer because you have a different context, different mood. Yeah, there's not, maybe you could phrase it, maybe there is not this one truth. Yeah? This is now becoming philosophical, but it's important to keep in mind. Yeah? You can have a 360-degree view on one specific task. This is why all these agents, these creepy agents, look into this portal in the center or something, yeah. And I want to give you also some examples of how this thing can actually look like. So this I presented for some keynote in a biotech conference. I was just Googling or Wikipediaing some biochemical reaction. This one here builds from glucose and ATP, glucose 6-phosphate and ADP. Yeah, so this is where the energy is produced in our body and or transformed in our body from ATP to ADP. And so I actually just created for any of these molecules an agent and told it, represent this molecule. Use the knowledge that you have and behave like realistically. And then I let them talk to each other. Yeah? So in this case, sorry, the prompt is German here, but I just tell it, hey, someone is putting energy into your system, so start with whatever. Yeah? I didn't really tell it with what it should start. It just told it also show your position in some way and diffuse. What happens when you meet? And so the agents worked out the scheme here, and they sort of created a matrix in which the molecules are sitting. And then throughout the conversation, you see the symbols in this matrix moving. And when they meet, they describe what happens and so on. So what happens in the end is basically they perform the reaction. Yeah? This is a very expensive way to simulate such a reaction. But it shows a principle. You can really use LLMs, give them a perspective, and let them work together to solve, to simulate things. Okay, I will not go into details this, but I found this is a very nice examples here. You can also see in the end, until they had their result for when I asked it to rise the temperature to 60 degrees, it used 20 messages, so they had like a free conversation and they exchanged 20 messages to get to this result. There are also different cases which I now on our own platform here played around with. For example, I built an agent that can access our GitLab, so I can always check the status of our repository, create new tickets with chat and things like this. Yeah, and this cost me an hour or so. Probably, because it's really easy. I created an agent, I asked it to tell me what I need to do in order to connect it with GitLab. It gave me all the code, I just had to enter my credentials, and then I was able to chat with it. And as you can see, it's even able to create plots for me. So just saying, I'm not sure how much BI will be a good job in the future anymore, dashboards and so on, because you can just on the fly with AI create your dashboards if you want. And on the right side, you also see how different schemes. It's weird. It's going a little to the. Okay. So this would be a hierarchical team setup where the human talks to some manager, so to say, and the manager gives tasks to sub-teams, which are all represented again by one representative agent. And the plot on the bottom right is supposed to show on the lowest layer you have the external systems. They are connected to the next layer, which are tools, so basically functions, code functions that can interact with these external sources. And they are connected to agents, and agents can be connected to agent teams, and agent teams can be connected to meta teams, and so on. Eventually, you end up having an application. And the nice thing is you can reuse the individual modules. So synergy use is very important here. I think this is also what industry needs to understand, because they all think in silos, they think in individual use cases, and reusing code is a drama, or assets, and also finding them, so knowledge management. Okay, I think as time is running, I hurry up a little bit more. Task separation is a very important principle here. We know this also from programming anyways, and from many other fields also with in organizations, how you set up teams, right? You want to have an expert or someone that has specifically this role and these tasks, and someone else having some other tasks, and have a sort of a clarity there, who is doing what. Yeah? And this principle of task separation has been shown to be very helpful in many, many different contexts, and as well for AI systems. But perspectives, in reality, come with opinions. If you have one specific perspective on a subject, or let's say even your presence or when you are born and raised in one country may give you a different perspective on the world, but also a different opinion, right? And I think opinions are very, very important. I see this in business all the time. It's all about politics. It's all about opinions of people in the end. Why do project fails? Because someone is not able to communicate properly with the other one, or has some fears or so, which are also expressed in opinions. So I want to highlight the human in actual applied AI applications. At least this is our rule that we are using always. Human is in the loop. The human is also on top of the loop. It governs the system. And the other alternative that we would have to sort of make sure that the AI is doing what we want is limiting the degrees of freedom. So basically destroying what we did when we built up the machine, the system. Yeah? We gave it a lot of degrees of freedom. It can answer all sort of different things. And then we tell it, don't answer this, don't answer this, this, this. And then we end up in a deterministic system again, which is, I don't know, it makes not so much sense. So I would prefer to keep the human there and have an eye on it, what's happening there, checking the results of the AI before sending it out and things like this. Yeah, again, perspective matters. There's a famous communication model from Thun, which basically also says that both the receiver and the sender have perspectives, have opinions, and proper communication needs to take into account both sides. And on the right side, there is a hint to an also very recent post from a very famous AI researcher, Andrew Karpathy, who is basically saying that humans are the ones that are empowered by AI, bottom up in changing sort of our digital world. Right now, one always has the feeling, yeah, these big companies are actually the one driving things, but in the end, probably similar to platforms like YouTube and so on, the users, the people that are able to create their own content, their own AIs, they will be the one driving what is actually happening. At least this is my perspective on it and my hope also, because I don't want to have OpenAI or so ruling our world in the end. Yeah. And let's try to sketch a little example how I used to map this down to a personal level. So maybe I'm Max Mustermann. This is a German term for talking about the average person. And I may have my personal AI assistant. May sit in the cloud or maybe on-prem on my computer if I have a super graphic card or so. It lives somewhere. And it's not only me. I also have a family. And what you see on the left side is a sort of a Wikipedia page, a Markdown file that has links to other entities, for example, to other agents. And in this Markdown files, I sort of describe who I am and what I like and what my values are, where I work, and I could basically write everything in there and create my own knowledge graph. Maybe some of you know the tool Obsidian. This I did with Obsidian. It's basically your own private Wikipedia. And you can also show your graph, your local graph. Here, Max Mustermann in the center. You have the circle around. What do I mean with the circle? With the circle, I want to say we have our private sphere. And we are the ones in control to decide what's going out of this sphere and what's coming into the sphere. Yeah? For us as humans, it's like our body and our sensors and our mind what decides what we want to take, what we don't want to take, and what changes our opinions. But you can also scale this up to a whole family, for example. You can also say someone is in charge in the family, usually it's the parents, and decide what can systems from outside bring into my systems and what I allow my assistants or agents to exchange with the external world. So this sort of shield, this data privacy sphere, if you want, is very important. And maybe you see also where this is going. And if you look onto the right side here, there's not only the Mustermanns, but also the Jetsons and also the Smiths, some multiple families. They are also interconnected because someone is friend with someone else and so on. So basically what you end up here is sort of also a representation of a social network. But it's not only social, like people in this network, but also some fishing agent, for example, because Max likes to fish. The daughter has a Tonybox agent, which helps her to order the newest episodes of something or so. And there are also AI tools as AI assistants there. This sphere that I plotted, I call the human bottleneck. And I have a reason why I call it bottleneck. In my perspective, I think we need to slow down AI systems to a natural speed, and that is us. So basically, if my AI system in my family at home does something, and it does it with light speed, because these systems are super fast and so on, then I don't want to have it in an automated way perform actions based on these super quick decision suggestions. I want to stop it, say, okay, you had your compute time, now it's me to decide should this go out or not. I think this is very important for the security aspects. Here sitting a lot of experts that probably could phrase this much better than me. But this is a really essential part of the whole story. So if I would play this game further and continue adding schools and public services and so on, of course you can blow up such graphs extremely, and you can query into these graphs with traditional graph query methods. So or like we work in a society. I start somewhere, for example, with Max, and then I have some question to the AI system, and it could sort of traverse the question to the experts for the specific topic. And interestingly, if you look at such systems, they have pretty much similarities with neural networks. It's basically just on a different level. Individual neurons are computers themselves. They are AIs themselves, if you want. They are very complex. This is often forgotten. And you could also imagine every of these dots here could be also on a different scale a neuron that is connected to other neurons. And you could have weights on the edges. And you could do everything that you can do with neural networks, at least with recurrent neural networks. It's just a little outlook here. Time is running, so I continue. Opinions, ownership, information about preferences, how you want to receive information and how you want to share information. You can all tell to the AI, it's no problem. You just need language. And you can do it in a poem form or in German or in English or however. AI understands it to some extent. And this is really nice. So this is the first time in history that we really can give private perspectives to a technology. And I also built an app with AI on the weekend to prepare this talk. It's not yet finished, but this is how such a system could look in practice. The graph view is not visible here, but you have this markdown wiki view where you can define the system prompt, the purpose of this agent, the tools that it's supposed to use, its capabilities, rules, maybe some metadata and configurations. You can all just write this in the file, give it to the agent and tell it, hey, represent this. And that's as easy how you can define an agent. And these systems can learn with us in the daily use. For example, we have a really big problem in Germany with the workforce because we have an aging society. In Deutsche Bahn, I think it's 250,000 people that are right now, empty positions right now. In the government, I think it's, well, not government, but public services is 350,000 also, because, yeah, we have an aging society and someone needs to learn from the old people before they go, so to say, before they are retiring. And this is often not happening, so we have huge gaps of knowledge. And this system can just adapt over time, because these systems can also automatically adjust these instructions. And also you can manually adjust these instructions. And the rest I will skip, just it will not take over. I had prepared some questions for you to sort of spark your fun and discussions about this topic. There are a lot of related topics like web search, SEO, what means influencing in the future? If the influencer has AI representative, how will things work out then? And yeah, with this, thank you for your attention. I hope you got some nice input. And
thank you, Johannes Megele.